Today in 1.4, we're going to look at rounding numbers as well as estimating. These are both really important skills, not just in math, but in math class rather, but in real life applications of math. So it's definitely something that we're going to spend a full section on and see how it relates. So the first thing we're going to do is we're going to round numbers to specific place values, and we're going to estimate some sums and differences, right? The results of addition and subtraction. And then we're going to look at some graphs and charts. So maybe you've rounded numbers before. Let's take a look at how to do it as an example together, and then we'll read the rules. So we'll follow the example in example 1. So it says round 5,382 to the nearest hundred. So it's really important when we learn to round that we already know our place values. So if I know all my place values, then it makes rounding much easier. So what I do, the first step when I'm rounding, first step is I identify the place value that I want to round to. So in this case, I want to round to the nearest hundred. So the hundreds place is right there. There's a 3 in the hundreds. That's why I read it 5,382. And so 300 is how many hundreds I have. The question is, do I have an amount that's closer to 300 or to 400, right? So if I had something like, let's say, 306, and let's say this is money, would it be fair for me to say that I have 300 bucks as a kind of an estimate? Yeah, I think that would be fair. Now compare that to something like, what if I have $389? Would it be fair for me to say, that's almost like I've got 400 bucks? And in fact, I might say that. I might say, I have almost $400, right? And so these are some ways that rounding really relates. So this little squiggly equals is the approximately equal. So 306 is, more or less like 300. And 389 is getting really close to 400. So the question is, though, when do I know to round up or to round off or down? Sometimes people say. So the question then really relates to not what's in the hundreds place, but what's in the tens place. What number is in the tens place? So what we do when we're assigned to round to the nearest hundred is we go to that place value and then we look to the right, the neighbor number. That number is going to help us to decide, am I going to round up or am I going to round down? And the short answer is that I'll round up whenever the neighbor number is 5 or more. And I'll round down whenever the neighbor number is 4 or less. So in the case of, let's say, so from 0 to 4, round down, and from 5 to 9, round up. Now, what are you rounding up? You're rounding up the place value that you were originally assigned to round. So in this case, the hundreds. So the neighbor number, right? Step 1, identify the place value to round. Step 2, look at the neighbor number. So I'll just say the NN, right? The neighbor number, the number on the right. Then you'll say, okay, then you have to make a decision, right? You have to make a decision up or down. Up, down. So up is 5 through 9. Down is 0 through 4. So the first 5 digits, 0 through 4, that'll round us down. That's closer to, say, 300, $300, $310, $320. Those are all closer to 300 than to 400 if I had to say it. But 370, 380, 390, these are all getting closer to 400. So it's not the place value I'm assigned to round, but the neighbor number that helps me to decide. Then once I decide, I round that original place value up or down, right? And by rounding it down, really I just leave it alone. So the options here are either it's going to be 5,300 or 5,400. And it's simply a question of, right, it's either going to be over here or it's going to be over here. And the question is, am I closer to the bigger number or closer to the smaller number? And that deciding point is right here at, let's say, 5,349 is right there on that side, and I would round that down to 5,300, and 5,350 is on the right. And anything 5,350 or above, I'm going to round up. Anything 5,349 or below, I'm going to round down. So the 5 is our cutoff point for rounding up. Everything else we round down or round off, because we're not really rounding the place value down. We're rounding off the tens and the ones in this case, right? We're saying these places here are going to go away, and I'm going to simplify this to be 5,300 or 5,400. In this case, the neighbor number is big, so 5,400. That's going to be our answer to this question. Okay, let's look at a couple more, just so we get some practice. So round 973 to the nearest hundred. Ooh, interesting. So if I had $973, would I say that's closer to $900, or is that closer to, well, what's after 900? Well, 9 is the biggest number that will fit in the hundreds place. So after that, we'll have to move into the thousands place. So 973 is pretty close to 1,000. And in fact, if I was thinking about it as money and I had a big bill to pay and it was $973, I would think of budgeting $1,000 for that, because it's so much closer to 1,000 than it is to 900. Now you might say, well, I could budget exactly 973, and you could, but if you had to give it kind of just 100 place value label, you'd prefer to say it's 1,000 than to say it's 900 because it's so close. So in this case, the process is the same. I write down the number, I identify the place value that I'm rounding. So I'm rounding to the nearest 100, but the 100 place value is not what helps me decide. That's the neighbor number's job. Now, is this 7 a big number or a little number? It's one of the big numbers. So it's actually going to push my hundreds up. Well, 9 goes to a 10. And where does that 1 go? It goes into the thousands place. So this rounds to 1,000. And now because I have something in the thousands, I need the comma. You might be able to recognize it without the comma, but that's the habit we want to be in. All right, let's look at example 4. Round 47,256,344 to the nearest million. So where's the millions? The millions, that's the sevens place, right? Or the 7 is in the millions place, because the 4, that first 4 on the left, is in the 10 millions place, because it's 47 million. So we go to the millions. Now, this is a big number, but the process is the same. We look to the neighbor number. Now, what's directly to the right of 7? It's a 2. Is that a big number or a little number? It's a little number. So what that means is we're going to round off. So 47,000, or excuse me, 47,256,344. I'm rounding to the nearest million, but it's the neighbor number that will help me decide. It's a 2, so what that means is we're going to round off. So essentially, we just turn everything after the place value that we're rounding to. We turn this all into zeros. Because even though 47 million is big, 256,344, that's big too. It's just not big enough to get us close to the next million. So in this case, since the 2, the neighbor number, was a small number, we round off or round down. Now, when you're rounding, if you're asked to round and there are calculations involved, then you want to do all your calculations first, get an exact answer, and then do your rounding. If you round as you go, then you'll get a different result, or you'll potentially get a different result. Okay, so that's kind of the segue into the next example. Example 6, estimate the answer to the following addition problem by rounding each number to the nearest thousand. So this is a little different than what we're doing when we're calculating and then we're rounding. This time we're estimating. And so when we're estimating, that is when we'll round before we calculate. So for rounding, we calculate first and then we round. If we're estimating, we round first and then we calculate. And the reason is because it'll be so much easier to do the math with simpler numbers that don't have as many non-zero place values. So let's have a look at this. So the answers, or excuse me, the terms here: 4,872, 1,691, 777, 6,124, and we're adding them all up. So the first thing we're going to do is because we're estimating, we're going to round first. So we're going to round all these to the nearest thousand, because that's what we've been asked to do, right? That was part of the problem. In your own life, you may round to different place values depending on what's appropriate, but typically problems in a textbook will tell you where to round to. So in this case, 4,872. Well, I want to round to the nearest thousand, which is where the 4 is, I look at the neighbor number, which is where the 8 is. 8's a big number, so that's going to push my 4 up to a 5. So 4,800 is pretty close to, excuse me, I had 800 on the brain, pretty close to 5,000 if I had to estimate. Right? 1,691. We're rounding to the thousands place, which is where the first one is over here. But really, it's the neighbor number, the 6, that helps me decide. 6 is a big number. It's going to push 1 up to a 2. All right, let's go to the next one, 777. And you might say, 777, how can I round that to the nearest thousand? There's no thousand place value here. Well, a couple of things about that. One is you could think of it as a 0, but really more importantly, the place that we round to is not necessarily what's important. It's the neighbor number that helps us to decide. So in this case, there might be a 0 here in the thousands place, right, if we were to write it. But the neighbor number is a 7, which is a big number. So 777 is closer to 1,000 than it is to no thousands. 6,124, well, 124, that's certainly a considerable number, but because we're rounding to the thousands place and the 1 is a small number, we can round it off. So it looks like 6,000 when it's rounded down to the nearest thousand. Now, when I sum these, it's much easier because I know the first 3 are the sums of all zeros. And then I can add just what's in my thousands place. So 5 and 2 is 7, and 1 is 8, and 6 more is 14. And I could carry the 1, but I have no place in the tens, in the 10,000s place to carry it to, so I can just bring it down 14,000. So this is not an exact answer, but it is close. And in fact, if I do the actual arithmetic, I get to 13,464. Now you can see how if you were to round this exact answer after you get it, round it to the nearest thousand, we'll look at the neighbor number. The neighbor number is a small number, so you would round this off. This would be closer to 13,000 rather than 14,000, right? Compare these two here. So this is the answer you get when you estimate, which is you round first. And this is the answer you get when you do all the arithmetic and then you round later. And you can see how it can make a difference which one you do first. And so it's really important to check out the directions and see what they're asking you to do. All right, let's have a look at some applications here. Oftentimes, whenever we see information in a chart, we may see some kind of rounded information or some averaged information. So working with rounding and estimating is not uncommon. So let's have a look at just some vocab here. So this is a bar chart, right, that's been made from this table. The data is the same. The information is the same. How it's presented visually looks different. Some representations are more useful than others. For example, if I'm really focused on what the numbers are and comparing the numbers, I may prefer the table. But if I'm focused on the kind of the visual impact that could have on someone, especially someone who's maybe not an expert, then graphs are a really good way to communicate. Charts, graphs can sometimes be superior to tables, especially if you have a lot of information. In this case, it's 5 different drinks. It's not a ton of information, but you could imagine if you had 50 different drinks, you might want to rank them like the bar chart rather than with a table. So it just depends on your application. Typically, you make the chart from the table, though. So you've got both often. All right, so let's also talk about a couple of things. This is the horizontal axis here. It's called the horizontal axis because it's horizontal, just like the horizon. And this is the vertical axis. And these are the two places that we're going to label our information, right? If you've ever seen, a chart before in kind of bar format, that it's always got these two axes typically distinguishing what the bar is, and then over here, so what is it? And then maybe like how high it goes. So maybe the money, the value of something, for instance, or the cost of something. So those are the axes. And notice how in the case of the vertical axis, it starts at 0, right? So we've got a really fair comparison. We can see that the tea and cocoa, they're pretty far apart in terms of their caffeine content. And we can see that visually. So let's do example 8. Refer to the bar chart shown in figure 1. That's the figure, the chart. How many milligrams of caffeine are consumed in one serving of instant coffee? So let's find instant coffee as a beverage on the x-axis, and then we follow it up until we have its vertical value. And if you didn't have this data call out here, this number 70 right there, you could just kind of follow the height of that bar all the way over to the axis and see, oh yeah, it's right at 70. So how many milligrams of caffeine are consumed in one serving? So we're going to say 70 milligrams, 70 mg of caffeine. And of course, that checks out with what we have in the table here, right? What we're trying to do is to practice reading both kinds, because you never know which kind you might get. And if anything, more often than not, you get the charts when you read things like the newspaper or an article. So let's review some of the key concepts here in 1.4. Go ahead and pause the video if you want to take a few minutes to do these on your own, and then we can go over them together. Okay, so I expect you to come up with your own answers to these questions because they are designed to test your understanding of a key concept that you could apply really now anywhere, because these rules for rounding, these rules for estimating, these rules, right, the way that we do things, right, is applicable to everything we do. So, A, describe the process you would use to round 5,382 to the nearest thousand. Now, we already did this one together, and you could go back and look at it, but I want you to try to recreate it from memory. So, what's the first thing we do? The first thing we do is we identify the place value. The place value of interest. So in this case, it's to the nearest thousand. Well, the thousands has a 5 in it. But that number doesn't really have much to do with rounding. It's the neighbor number, right? It's the 3. It's the number to the right of the place value of interest that we really use to make our decision. So look at the neighbor number. That neighbor number is small, right? It's 0 to 4. So we round down. If it had been 5 to 9, we would have rounded the place value of interest up. So keep that in mind. What do we round up? It's not the 3 that's in the hundreds. That helps us to make a decision about the thousands place. And in this case, we're rounding down or off. So 5,000 is closer to 5,382. Now let's look at B. You describe the process you would use to round 47,256,344 to the nearest 10,000. So this is the same number we got before, but to a different place value, right? Oh, and I suppose the other one was too. So let's have a look at this to the nearest 10,000. So I've got to identify the place value. There it is. It's got a 5 in it. But that's not what helps me decide. It's the neighbor number that helps me decide, the 6. 6 is a big number. So it's going to push. 56 is closer to 60 than to 50. So 6 pushes my 5 up. And so this would round to 47,260,000. Notice I keep everything before the place value of interest. So the 47,200,000 piece, that's not going to change. It's a question of will it be 250,000 or 260,000 since I'm rounding to the nearest 10,000. All right, so that was B. We did that one right on the screen there together. Let's look at C. Find a number not containing the digit 7 that will round to 700 when rounded to the nearest 100. Oh, okay. So let's look at a number like 683. There's no 7s in it. However, if I round it to the nearest 100, that's this place where the 6 is, it's the neighbor number that helps me decide. The 8's a big number, so it pushes my 6 up to a 7. So 683 is pretty close to 700. And the rules for rounding, right, whether you're halfway to the next number or not, that's what matters. Okay, now here's part D. And this is sort of the final test. And this is for you to really think about a time when you use rounding and estimating in your day-to-day life. And so I'm sure you can think of lots of examples, and there are lots of examples, right? In fact, you probably can't get through a day without a relevant example. But what I would say is that one place I use it is for gas. So I like to estimate how much I think I'm going to spend on gas. So if I know that my gas tank holds about 12 and a half gallons, and I see the gauge, right? Here's the gauge, there's full, there's empty. I see the gauge and it's on, let's say, I guess I need another one for half full there. Let's say it's on, uh, oops, I didn't want to change everything there. I just wanted to show you, let's see. I guess I just wanted to show you, what if it's at a quarter tank? Okay, so if it's at a quarter tank, let's see. Half of 12 would be 6, and half of 6 would be 3. So there's like 3 gallons in each one of these little quarter tank sections on my gas gauge, approximately, right? And so if I go and I've got a quarter tank left, I'm expecting to get, anywhere between 9 and 10 gallons of gas. And if gas is, say, $3, and I'll go with a nice low number from maybe a few weeks ago, 307 per gallon, right? That's for 1 gallon. And I'm getting about 10 gallons. 10 times 3, oh, that's about $30 that I'm going to expect to spend on gas when I fill up. And so then I know if it shuts off way early, then maybe something was wrong with the auto shut off. Or if I see it get up into 34, 35, then maybe I've got an overflow problem, right? So I want to, go back to the pump and certainly watch it anytime it gets close to my estimate, because I know I'm getting close to full and it should auto shut off. So that's just one example. I'm sure you're going to think of something different and something interesting, and I hope that you'll think about all the different ways you estimate and round throughout the day. So that was 1.4, and we'll see you back for 1.5.